The question is telling us to give the maximum combination sums. In the question, we have been provided with nums1, that is one array, and nums2, that is another array, and an integer k. The question is telling us from both the nums array, we have to make all the combinations from that, and we have to sum them. Each combination we have to sum, and we have to return the maximum sum combination. The question mentions over here that a valid sum combination is made by adding one element from nums1 and one element from nums2, returning the answer in non-increasing order. So the question is return here. I'll explain you what it is. See, we have one array that is nums1 and we have another array that is nums2, and we would be given k, an integer. So the question is like we have to make all the combinations from both these nums1 and nums2, and we have to sum each combination, and we have to return the maximum 2. Here case 2, so we have to return the maximum 2 sum combination. So all the combinations of this both the nums, let's see, we have 7 and 3, 1 and 6. So both the combinations would be 7 and 1 would be one combination. If I sum both of them, it would be 8. 7 and 6, it would be another combination. This would result in 13. 3 and 1 would also be one combination. This would result in 4. And 3 and 6, this would be another combination which would result in 9 if we add them. These are all the possible combinations that we can take from these two arrays. Okay, we have 4 of them combination. So I want you to look that the first sum is 8, second is 13, 4 and then 9. What we want, the question tells us we have to return maximum sum combinations that are k. Like k is given in this question is 2, so we have to return two maximum sum combinations. So by looking here, we see that 13 is one maximum and 9 is one maximum. So the answer for this question would be we have to return 13 comma 9 for this. In such a way, we would be given k's, k integer, and we have to return those many maximum combination sum, and the constraint of k is it would be always less than the length of elements in the nums array. I would take another example that would make you understand better. For this example, if you want the maximum combination sum, so we have three elements in nums1 and three elements in nums2 as well. So if we take the combination, all the combinations, that is if I pair 7 with first 6, 7 with 6, my sum would be 13. If I pair 7 with 1, 7 with 1, my answer would be 8. 7 plus 1. The sum would be 8. Now, similar way, I would pair 7 with 3. My sum would be 10. Now 2 with 6, 2 with 1, and 2 with 3. Here we have also done. And now the last combinations with 4 would be 4 plus 6, 4 plus 1, 4 plus 3. Now we have entire all the combination sums. Now we have to return the k, that is the k is given here 3. So we have to return 3 maximum combination sums from all these combinations. So as I have marked here, the greatest is 13, then 10, then 10. So for this question as well, we have to return the answer array as 13, 10, 10. The answer for this example would be this. So I think you have understood the question, and how to solve it. So let's discuss the brute force approach for solving this question. The brute force approach would be that I would the same way I would do all the maximum combination sums. I would store all of them in an answer array. I would sort that in a decreasing order, and then I would return the maximum k maximum combination sums. K, what would be given in the question, if k is 2, in that case I would return 2 maximum combination sum. So this approach that I used to explain you is brute force. So if we try to implement this, it would give us time limit exceeded, and it is not a good approach. So let's see how do we do with optimal approach. The optimal approach for this would be, we have nums1 and nums2. The first thing we have to do is sort them in decreasing order. So my nums1 was 7 2 4, so I would sort them in decreasing order, so that would become 7 4 2 my nums1, and my nums2 is 6 1 3. So if I sort this as well in decreasing order, this would become 6 3 1. Now the first step we have done is sorting them in decreasing order. Now we would use max heap and set data structure to implement this solution. I would explain it, just wait. So how can we solve this using heaps and sorting? See, if I have sorted both this array in decreasing order, it is very obvious that the maximum element in the entire array would come and sit at the first index. The same way, the nums2 would also have the greatest element at the first index. So what we wanted is, we wanted the maximum combination sum. So if we sum this, and obviously this would be the maximum sum in the entire array. So that would be 7 plus 6 is 13. This is the maximum sum. Now what we will do, we would store this 13 in heap with its index is 0 comma 0. What is 0 0 here? 0 0 is, this is my ith index and this is my jth index. Ji is pointing to nums1 first, like 0th index element, and j is pointing to nums2 0th index element. So I would add in my maximum heap 13, the maximum sum that I got by adding the first elements of both the arrays and their indexes as well. Now what I will do, this both the indexes 0 comma 0 I would mark in the set, that I should know that I have visited both these indexes. Further, I should not visit this 0 comma 0, so I am adding in this set data structure. Just wait, I would make you understand everything. So let's continue the dry run. So I wanted 3 maximum combination sum. I have got 1 here. So I need further 2 more combination sums. So what I will do, the I pointer was pointing to 0 and j pointer was also pointing to 0. What I will do, I would increment one of the pointers I plus 1 comma j, or uh, j plus 1 I comma j plus 1. I would search in both these indexes of the arrays that can I get another combination sum maximum. That means that I plus 1 j. So I was pointing to here and j was pointing to here. Now I want to check, is I plus 1 this element and my j this element. If I do their sum, can I get another answer? So what I will do, I plus 1 j is I plus 1 is 4, and now j here is 6. So 4 plus 6 is 10. Okay. So what I will do, I would further add this into the max heap and mark this I plus 1j as visited in my set data structure. Before adding these two, we would remove the 13 comma 0 comma 0 these indexes from the max heap, and we would store that in my answer vector. We would store only 13 in my answer vector. Now what I will do, I would add this 4 plus 6 10 sum in my max heap with the indexes I plus 1. I plus 1 is, these are the indexes 0 1 2. So I plus 1 is, index of I is 1 and index of j is 0, because we had taken 4 and 6, so 1 and 0 the indexes we add. Now we would try for I comma j plus 1. I was 0 initially, so we would take 7 plus j plus 1 is 3. This is also resulting to 10. Now we would add this as well in my max heap for this iteration. So it would come 10 comma I is 0 and j plus 1 is 1. Okay, so we have added in the heap data structure, and we would also add in the set data structure that these are visited. So previously we had visited 1 0 and 0 1, so that further we should not take or come and visit these. For the next iteration, when we come, we would remove the top element what we have in the maximum heap, because it is getting sorted with the sum, because we want the maximum sum. So here 10 we would remove and store in the answer vector. So this is removed. Now to further check our answers, we would take from the max heap dot top what element is there. We would take the I and j indexes, and we would compare that further can we get the answers. Now the question k was 3, we have got two answers, we would need further one answer. So here I is 1 and j is 0. So I is 1 here, I is 1 and j is given as 0. This is my weight, this is my j. Okay, now I would further check I plus 1 j and ij plus 1. So I plus 1 is 2. So this is my I and this is my j. I would further check I plus 1 j. Is this a valid combination sum? So I plus 1, I was 1 here. So I plus 1 is 2. 1 plus 1 is 2. So I would check 2 and j. 2 plus 6, it is 8. So I got another sum, and I would also check I comma j plus 1. I was 1. So j plus 1 would be this, it would be this. So 4 plus 3 equals to 7. We have got another 2, but before adding these two, we would remove the top element heap, max heap. When we try to do a next new iteration, we would remove from top. So we would remove this top 10 1 0, and we would add in my answer array. So I have got here three answers. The k required was 3. Then I would add both these 8, their indexes. 8 index was 2 and 6, that is 2 comma 0, and the 7 was 1 comma 1. Now when I go for the next iteration, it would tell me that I have reached my k answer. So this is the dry run. I will show you the pseudocode. It's very easy to understand. Let's go. I would explain you the pseudocode. Before that, this is the C++ implementation. I have written like I have given the Java and Python code as well. So let's see the pseudocode, how we can get that. The pseudocode, we are taking the size n, then we are sorting them in decreasing order, both the nums1 and nums2. Now, as I have told you, we would create a max heap and a visited set that would store my all the indexes that I had reached. The first thing what we would do, the, as we have now sorted them in decreasing order, the first element that we had seen above would be the greatest element from both the arrays. So I would add both the arrays and their indexes 0 0 into the max heap as we had done previously, and mark the 0 0 as visited, because that would give me the first biggest combination sum. Now next, this is a while loop while k is greater than 0, because we want k maximum combination sums and max heap is not empty. Till then we would do the iterations. So we would take from the top, as we were doing every time when we start the iteration. We would take from the top of maximum heap the current sum, the ith index and jth index, and then we would append that current sum to the result answer array that we had done. Now we would check I plus 1 is less than n to check, are we going out of bounds? No. So to check that, we are using this condition I plus 1 less than n, and we would check I plus 1j, are they visited? That the set, now you understood the set why we were using, to check that we shouldn't go for those indexes that we have done, like we have taken it previously. So I plus 1j, we would check, are they visited? No, no, now they are not visited. So in that we would push nums I plus 1 plus nums 2 j, like the combination sum, and we would also append the I plus 1 index and j into the max heap. Now we would mark I plus 1 j as visited because we have taken this combination sum. The similar way, as I had told you, we would also take I comma j plus 1, those two, every time we were taking those two. No, so we are taking similarly here also, and the out of bound checking is j plus 1 less than n. Similarly, we would check, are they visited? No, no, they are not yet visited. So we would push them nums1 I plus nums2 j plus 1. We would sum these two and we would add in the max heap, and then I comma j plus 1, their indexes, into the max heap. We would mark them visited, we would decrement the k. Similarly, for the next iteration, the first thing in the max heap we have added these two. No, these two, the max heap, what it will do, it max heap property is it would take the maximum sum, combination sum that we had done. No, it would take it to the top. So when we have that top, for the next iteration, pop from max heap, we would take that top element, we would add in the array, the result array. Similarly, this would go on and we would get the k combination sums. So this way, the C++ implementation is the same thing what I have written in the pseudocode. So that is entirely same. It's just in syntax of C++. The Java is also the same logic. Intuition is the same. It's just written in Java syntax, and Python is also the same. So if you have found this video helpful, please like and share. Thank you.